Hello, my name is Chuan-en. I'm going to present Architect, Building Interactive Virtual Experiences from Physical Affordances by Bringing Human in the Loop. This is joint work with my colleague, Cheng, and my advisor, Xiaojuan at the HKUST HCI group. When you play a virtual reality game, you are usually restricted to a small confined area as to not bump into physical objects in surroundings. A typical setup may be a headset with two controllers. For example, you may use your controllers to control your in-game character to walk. However, prior work has shown that real walking in VR actually strengthens virtual presence. On the other hand, we also argue for the benefits of blending common physical objects in the user's surrounding environment as passive haptics in the virtual world. For example, a physical umbrella may be repurposed as a graspable virtual shovel to elicit haptic feedback. We present Architect, a proof-of-concept prototype which facilitates the flexible construction of an interactive virtual experience that allows both real walking and physical interactions. In our work, we exploit the asymmetric dynamic between the worlds of two users, one as the assistant in AR and the other as the player in immersive VR. We capitalize the distinct perspectives of the shared experience through a simple yet effective authoring workflow. As the assistant walks through the environment, the mobile device scans the scene, and coarse geometries such as horizontal planes are highlighted to aid the assistant. The assistant, who sees the physical world, then superimposes physical objects with virtual proxies in consideration of affordances to design a virtual world. To aid the assistant, our system also recommends virtual proxies based on interaction affordances of in-situ objects. After the assistant finishes mapping the virtual world, the mobile device is switched to VR mode, encased in a Google Cardboard, and given to the player. The player may then experience the virtual world built by the assistant using the physical world as a template, with physical interactions and real walking. We conducted a within-subjects user study with 18 participants to evaluate participants' experience of presence, trust, and workload between Architect and the baseline. More specifically, we measured the presence, trust, and workload of the player and the workload of the assistant after experiencing each system. In the baseline condition, the player was required to complete the same tasks without interactable virtual proxies embedded using Architect. Instead, the assistant guided the player through vocal instructions to interact with the physical environment. User study results were analyzed through a one-way repeated measures ANOVA. Generally, participants reported a significantly higher sense of virtual presence, a significantly higher sense of trust, and a significantly decreased workload when using Architect compared with the baseline. We further implemented 3 example experiences to demonstrate Architect's ability of supporting the assistant from 3 directions: repurposed design, level design, and personalization through modular design. In Lava Escape, we explore the benefit of Architect for in-situ repurposing of everyday objects into game elements, without the need for specialized props to fit a storyline. The experience also examines the assistant's ability to select appropriate physical objects for mapping, such as stable objects to be stood on, as well as the ability to accurately fine-tune the size, orientation, and scale of virtual proxies for a reality-based virtual environment with strict mapping requirements. In Maze, we explore the use of Architect for level design while reusing the physical environment. We explore the usage of fake barriers and obstacles to manipulate the concept of space in the virtual world under an asymmetric setting. Hence, with Architect, the virtual world may be designed to have a greater variety and be far more complex. An interesting area for further exploration may be its usage for designing redirected walking experiences, where players explore a virtual world that is deceivingly larger than the physical configuration offered in reality. In Stanbox, we illustrate the ability to create personalized experiences by exploring the modularity of Architect. Stanbox is a testbed for assistants to establish their own game theme and configure their own set of virtual proxies for different components of the virtual world. In Stanbox, we also explore the possibility of incorporating a physical controller into the virtual experience, perhaps even extending to haptic actuators to blend active haptics. To summarize and conclude, we presented Architect, a proof-of-concept prototype which facilitates flexible customization of a virtual experience based on the physical environment. By bringing human in the loop, Architect provides the assistant an AR interface with scene understanding aid to translate affordances of physical objects to interactions with virtual proxies. We conducted a within-subject study comparing Architect to a baseline condition, the assistant guiding the player through verbal instruction, showing a decreased perceived workload for assistants and players, and increased VR presence and trust in the assistant for players. We further provided guidelines for future designers of Architect and implemented 3 example experiences for demonstration. We would like to thank all the participants who volunteered for the user study, amazing people at the HKUST HCI group for providing valuable feedback on iterations of our system and paper write-up, and the anonymous reviewers for their comments. Thank you for listening, and we hope the design space we presented in this work will help inspire new angles of exploration for VR experience authoring. For more information, please check our project page for paper, video, and more.